Well, hello there, Mary.
Hi, Grandpa. Ooh.
Hi, sweetie.
Hi, Dad. Well, Mom said you went for a walk, so I figured you'd be at Grandpa's.
Where are Jack and the kids?
Well, the kids are at Mom's, and Jack's been at the dealership all week studying up on the 1994 Buicks.
Well, that means that he'll be busting to tell us all about him when he gets here.
Oh, you know you guys love it when Jack raves about his new Buicks.
Hey, how about some lemonade?
You know, I would love some, but I promised Mom I'd be right back to help for dinner.
Oh.
So, I'll see you guys.
We'll see you later.
Right,
Let's get some of that lemonade.
Now we're going to hear about those 94 Buicks, aren't
Oh,
we?
yeah. Here we go.
Hey, don't you two ever do any work around here?
Well, hello there, young fella.
Hi, Grandpa.
Hi, Jack.
Hey,
How was
Dad.
the drive up?
Oh, not too bad. I made pretty good time. Although I did have a near miss with Tom Kelly's tractor on the back road in.
Oh, yeah?
Yeah, I think it was the oldest boy driving. He came right up over the ditch and onto the road. Never even checked to see if anybody was coming.
Lucky you didn't hit him.
I'd have hit him for sure if the Park Avenue I was driving didn't have ABS.
There he goes with that technical talk. What the heck is an ABS?
ABS stands for anti-lock brakes. You should know that. You have ABS on your Regal.
Oh, I'm just kidding you. Of course, I know I've got anti-lock brakes, and you encouraged me to get them. But, you know, to tell you the truth, Jack, I don't think I can tell any difference.
Well, most of the time you won't notice much difference. Because most of the time, during normal braking, ABS isn't needed. But when you do need it, believe me, it really can make a big difference.
In other words, if you hadn't had ABS, you think you couldn't have stopped?
Well, there just wasn't enough time to stop, period. Although it can reduce stopping distance, what really saved me was the way ABS allowed me to take control of my car while I was braking very hard, so I could steer to avoid him.
Must have given you quite a scare.
It sure did, but I think the Kelly kid had a bigger scare than I did, judging from the color of his face.
Well, sometimes we don't appreciate technology until we really need it.
You know, that's so true. We were just discussing that last night at the dealership. Buick has made a tremendous number of improvements to their 1994 models, but subtle improvements. Yet some customers, most customers, will hardly be aware of the changes until they discover the advantages for themselves.
I think we're about to hear those improvements.
You bet. And real soon, too.
For instance, the Park Avenue, Ultra, and Lesabre models are equipped with a terrific new traction control system.
Excuse me, son. I don't mean to tell you your business, but I've got traction control on that Park Avenue I bought almost a year ago.
Well, that's true, Dad, but this is a new system. It's more sophisticated.
Well, the one on your dad's car is plenty sophisticated for me. I understand that the computer can actually put on the brakes if your wheels are spinning.
During acceleration, that's right, Grandpa. An electronic brake and traction control module, we call it the EBTCM, monitors front wheel speed.
There he goes with the ICBMs.
And if the EBTCM detects slipping, it pulses the brake at that wheel to produce more traction. But the new interactive traction system does much more than apply brakes. Its EBTCM is connected to the engine computer, Powertrain control module. So in addition to applying brakes, the EBTCM signals the PCM to reduce engine torque output.
So now your computer has control of your accelerator as well as the brake?
Well, not exactly. What the EBTCM does is it requests the PCM to reduce engine torque output by a given percentage, an amount based on how much wheel spin it senses. Also, the new traction control system can be shut off using a switch in the instrument panel.
So that you can spin around and make donuts, eh?
Well, you might want to do that, Grandpa, but for regular folks, it was more intended for other situations, like when you want to rock your car backward and forward to get out of a deep snowdrift.
How is this new system better than the traction control I've got?
Well, reducing engine torque allows smoother, more accurate control of wheel spin than the brake-only method. Also, the system on your 1993 car was designed to operate at speeds below 25 miles per hour. This new system operates during acceleration at any speed for added safety.
Well, safety is getting to be a big thing on cars.
Very much so.
A good example of a major new safety feature is a passenger side airbag that's standard on the 94 Park Avenue, Ultra, and Lesabre models. When the car is involved in a frontal collision with an impact force equivalent to a speed of about 14 miles per hour, the supplemental restraint system is activated. When this happens, the driver and passenger inflator modules inflate the airbag simultaneously to help protect both front seat occupants. The 94 Roadmaster is also equipped with both driver and passenger side airbags. The instrument panel is totally redesigned and has a hinged door on top for deployment of the passenger side airbag. The 94 Roadmaster also has a completely redesigned optional automatic air conditioning system with a new control panel mounted higher in the instrument panel.
This system has a memory feature that retains the previously selected climate settings after the car shut off.
You know, for years I drove Roadmasters. Right after the war and through the 50s, when they stopped making them. Boy, were they beauties. Roadmaster was always a big, powerful car.
But the Roadmaster is still a big, powerful car. In fact, for 94, it just got even more powerful. The new LT1 5.7-liter V8 puts out 260 horsepower at 5,000 RPM, and torque is a massive 330 pounds at 3,200 RPM.
Must use a lot of gas.
Actually, no. Even with all the extra output, the new engine produces less emissions, runs quieter, and uses less gas than the current LO5 V8. It should get about 17 miles to the gallon in the city and 25 on the highway.
A major reason for the increased power and fuel efficiency is the new engine's fuel delivery system. The throttle body injection system of the 93 engine is replaced by sequential fuel injection with individual Multec injectors for each cylinder. The power of the LT1 engine is transmitted to the rear wheels by means of a new 4L60E transmission. As with the front-wheel drive 4T60E transaxle, the E stands for electronically shifted. In fact, the 4L60E shares many of the electronic operating features that make the transversely mounted 4T60E one of the smoothest shifting automatic transaxles available. The Roadmaster Powertrain control module monitors signals from sensors that indicate information such as vehicle speed, throttle position, coolant temperature, engine speed, engine load, converter turbine speed, transmission fluid temperature, and so on. The PCM uses all of this information on actual vehicle operating conditions to control fluid pressure, precisely time transmission upshifts and downshifts, and smoothly apply and release the torque converter clutch.
It sure sounds like a heck of a piece of engineering.
Well, it is. But actually, the electronic design eliminates a lot of pretty complicated mechanical parts, like the governor, the throttle valves, the auxiliary...
Oh, now you're sounding more like an engineer than a salesman.
Well, it helps me sell them better if I know how they work. But if it's a salesman you want, how about letting me sell you a new Regal, Grandpa?
Not so fast. I'm perfectly happy with the one I've got. Although I am curious to know if they've changed it at all for 94.
Well, it still looks the same, but the 94 Regal gets a whole lot of improvements. Let me think. Well, for one thing, the 94 Regal has the Passkey 2 theft deterrent system. That's with this little identification pellet in the ignition key. The car won't start unless you use the correct key. If the PCM doesn't see the correct key pellet, it won't allow the fuel injectors to operate. Anti-lock brakes are standard on all 94 Buicks, but the Regal also has some new brake hardware.
In addition to a larger capacity booster, there are new rear brake calipers and larger rotors. The brake pads are also larger. They say that should give us a 35% improvement in pad life. Oh, and speaking of brakes, Regal, Lesabre, and Park Avenue are all equipped with a handy new push-to-set, push-to-release parking brake instead of the separate release handle. Another subtle change is in the cruise control system. The vacuum-operated servo unit is replaced by an electronic cruise control module. It's like the cruise system used on Roadmaster. Of course, Regal has the new design 4-spoke steering wheel that is standard across all our 94s. But in Regal, you can get the optional radio controls right on the wheel. This steering wheel with radio and climate controls is also available on the 94 Park Avenue and Ultra models. The horn pad on the new wheel extends over the airbag for easier use of the horn. So you can get the optional steering wheel radio controls and have an airbag as well.
Your grandma claims she's been riding around with an airbag in that Regal all along.
What are you saying about Grandma?
Hi,
Hi, honey, how are you?
Good.
So what are you guys all excited about?
Oh, listening to Jack sell us his new Buicks.
He's good at that, isn't he?
He sure is.
So what's new with the Skylark for 94? I hope you told those Buick guys I like it just the way it is.
Don't worry, honey. I know you're really going to like the new Skylark features. Even the details, like the way the interior lights stay on when the doors are unlocked, and then dim gradually, like in a movie theater.
That sounds nice.
The 94 Skylark is also equipped with a new console-mounted transaxle shift control. Beneath the shift lever is a new electronic Prindle control module with LEDs that illuminate to indicate the selected gear position. As I said, all 94 Buicks have the new steering wheel with driver's side airbag as standard equipment, and of course, the anti-lock brakes are also standard. The automatic door locks still lock when you shift out of park. But now the doors unlock automatically when the ignition key is turned off. However, for those people who prefer that the doors remain locked when the key is turned off, all they have to do is remove the 10-amp fuse labeled lock from the fuse panel. If a passenger unlocks and opens the door when the shift lever is not in park and the brake pedal is held down, the door will relock automatically when it is closed again.
You know, that really would come in handy when I drop David off at school. You know, I better make sure that he's not bugging Grandma for more cookies.
The optional engine for the 94 Skylark is a new 3.1-liter V6.
Is that like the 3.1-liter V6 I have in my Regal?
Well, it's based on it, but the Generation 3 3100 is virtually a new engine. For one thing, the 3100 has sequential fuel injection. That means the injectors deliver fuel into the cylinders in the same sequence as the ignition firing order, so it uses fuel more efficiently. There's about 25 more horsepower. It's up to 165, and torque is also increased from 185 to 190 pounds. For smooth shifting, the 4T60E electronic transaxle is used in conjunction with the 3100 V6. This 3100 engine and 4T60E powertrain combination will be standard on Regal Custom and available on the 94 Century. The base engine for the 1994 Century is the 2200 2.2-liter L4. This engine has received a number of enhancements designed to reduce friction and increase performance.
You know, for a year when there are no new models, Buick has sure made a lot of changes.
You bet. And there are a whole lot more I didn't even get to.
For example, all 94 models use the new R134A refrigerant, which is free of CFCs.
The things that the scientists say are eating holes in the ozone. Chlorofluorocarbons, right?
That's it.
And speaking of eating, I could sure go for some dinner right now.
I think you'll agree there are a considerable number of technical refinements in the 1994 Buick models. Now let's look at some of the new systems in more detail for Buick dealership service personnel. As we've seen, all 1994 Buicks are equipped with supplemental restraint systems with driver side airbags. Park Avenue, Lesabre, and Roadmaster also feature passenger side airbags. Let's highlight some of the service-related features of the Park Avenue and Lesabre supplementary restraint system. Although they are both activated at the same time, the driver and passenger airbags each have their own deployment loops. A new dual-pole arming sensor, located high in the steering column support,
controls the power side of both the deployment loops. The dual-pole arming sensor contains a weighted rotor with gold-coated electrical contacts. A spring holds the rotor so that the contacts remain open during normal operation. When a collision of sufficient force occurs, a weight on the rotor overcomes the spring tension and the electrical contacts close, allowing current to flow in the deployment loops of both airbags. The previous Park Avenue and Lesabre driver-side-only airbag system used 2 discriminating sensors. Now 3 discriminating sensors act as protective switches on the low or ground side of the deployment loop. As before, the forward discriminating sensor is mounted by the radiator. The passenger compartment discriminating sensor is replaced by 2 mid-rail discriminating sensors. They are mounted on the forwardmost engine support rails on both sides of the car. The Diagnostic Energy Reserve Module, or DERM, is located under the center instrument panel in the area where the anti-lock brake system, EBCTM, was previously located. The Roadmaster supplementary restraint system also incorporates a passenger side airbag, but there are considerable differences in the deployment loop components. The biggest difference is that instead of a DERM, the Roadmaster uses a new Sensing Diagnostic Module, or SDM. The SDM performs the system diagnostic, energy reserve, and deployment functions of the DERM. However, it also contains a small dual-pole arming sensor and an electronic accelerometer that can sense a sudden large change in velocity, such as during a collision. So although a single forward discriminating sensor is still used, the SDM can deploy the airbags by itself, based on signals from its internal sensor. While we're looking at the '94 Roadmaster, let's take another look at the new LT1 V8. Although it has the same displacement, the LT1 engine is a completely redesigned version of the familiar GM 350. There's an all-new one-piece aluminum intake manifold and new cast-iron cylinder heads. Noise-reducing cast-iron exhaust manifolds feed dual stainless steel exhaust for improved engine efficiency. The individual upfront catalytic converters heat up quickly to reduce emissions during startup. The LT1 uses an electric air injection pump. The electric pump runs more quietly than the belt-driven pump while consuming no engine power. Also, it operates only when needed to inject air into the exhaust manifold during cold startup. At first glance, one of the most noticeable changes on this new V8 is the new gear-driven water pump. This more durable design eliminates pump load on the engine accessory belt, and it ensures that the pump continues to function in the event that the belt should break. Another major change is that coolant flow through the engine has been reversed. This arrangement helps keep the cylinder head and combustion chambers cooler and allows a compression ratio of 10.5 to 1. Coolant enters the top of the engine first, allowing more even distribution of combustion heat. Engine cooling during stop-and-go driving is further improved by the use of dual cooling fans. There are 3 available cooling packages. This is the trailer towing or grand touring version, the heaviest duty cooling system. Here, the 7-blade engine-driven fan is used with a 240-watt electric secondary fan. 2 other cooling combinations are available, both using dual electric fans. The size of the electric fans varies depending on which of 3 cooling capacity options is chosen. The standard duty cooling system uses one 100-watt fan unit and a 150-watt fan. On the heavy-duty system, the 100-watt fan is replaced by a 240-watt unit. The Roadmaster also has a new brake booster that provides more brake assistance by increasing booster volume from 240 to 260 cubic feet per minute. Located behind the LT1 water pump is one of the most significant new features of this engine, the distributor assembly for the ABITS, or angle-based ignition timing system. The distributor is driven directly off the engine camshaft. Base timing is not adjustable. Inside the distributor assembly is the rotor that distributes secondary ignition coil current to the platinum-tip spark plugs. The rotor design incorporates a wide electrical contact segment for improved wear and lower radio frequency interference. The rotor tail is also wide to provide excellent rotational balance. The OptiSpark angle-based ignition timing system uses a pickup assembly with a dual optical position sensor and a rotating sensor disc. The optical position sensor is mounted so that two pairs of LED photodiodes line up over two tracks of slots on the disc surface. The outer, or high-resolution track, contains 360 equally spaced slots. The inside, low-resolution track contains 8 slots with varying widths. When properly positioned, the beginning edge of each slot corresponds to the top dead center position of a particular cylinder. As the camshaft rotates, the slots on the disc produce signal pulses from the optical sensors to the PCM. The PCM calculates spark delivery, crankshaft, and cylinder position by counting the number of high-resolution signal pulses received when the low-resolution signal voltage is in a low state. The high-energy ignition coil is mounted separately. The ignition coil driver, or ICD module, located just above the coil, replaces the internal module used in previous HEI distributors. Because the A-bit system always operates in electronic spark timing, or EST mode, with the PCM controlling spark advance at all times, the ICD module has fewer functions and is smaller than the HEI module. The PCM calculates spark advance and coil dwell based upon the low-resolution timing signal, TPS and battery voltage, as well as the signals from the coolant sensor, MAP sensor, MAF sensor, and NOx sensor. Also, spark advance is modified during EGR flow and TCC release. Located under hood, the 1994 Roadmaster PCM is a new high-speed unit, the 66U. This has bidirectional scan capabilities for improved diagnostics and a reprogrammable hardwired MEMCAL. Inside the top of the PCM is the NOx sensor module. For improved sensitivity, 2 NOx sensors are used, one on each side of the LT1 engine. Also, 2 heated oxygen sensors are used, one on each side, for improved emissions control. The hot wire style mass airflow, or MAF sensor, is located at the air cleaner inlet. The MAF signal is used to calculate fuel delivery and canister purge rate. The MAP sensor is also used as a backup and to control certain engine functions. The angle-based ignition timing system provides more diagnostic codes than the previous Roadmaster ignition system. An open, shorted, or grounded low-resolution signal, for example, would set a code 16. Other new ignition system codes are 36, 41, and 42. Now let's take a look at the new 4L60E transmission. The Roadmaster 4L60E transmission uses a number of new components. There are 2 identical shift solenoids that control the 1-2 shift and 2-3 shift valves, and also a 3-2 downshift solenoid. A transmission pressure control solenoid, or force motor, takes the place of the throttle valve and controls line pressure. The PCM can match transmission line pressure to engine load by changing the duty cycle of the force motor in proportion to the throttle position. For example, current flow in the solenoid coil increases with the duty cycle from 0 amps at maximum throttle and 0 duty cycle to 1.1 amps at minimum throttle and 60% duty cycle. The transmission fluid pressure switch assembly contains a set of 5 pressure switches that sense fluid pressure in 5 different valve body passages. These switches are wired to provide 3 signal lines to the PCM. The PCM monitors the signals to determine actual manual valve position. The transmission temperature sensor is also contained in the pressure switch assembly. The PCM can engage the TCC when transmission temperature is excessive. Although there are obvious differences between the 4L60E transmission and the 4T60E transaxle, the service and diagnostic procedures are similar. A Tech 1 scan tool can be used to read diagnostic codes. The Tech 1 can also be used to manually activate the transmission fluid pressure solenoid while checking line pressure in park and neutral. Earlier, when I was describing the Park Avenue's new interactive traction control system, I mentioned the EBTCM could now command the PCM to reduce engine torque output. In addition to applying the brakes, the EBTCM can control wheel spin in varying degrees by using the PCM to command a number of engine control strategies that reduce engine torque output. It can retard spark timing, command a leaner air-fuel ratio, command the EGR valve to fully open, and it can shut off fuel delivery to 3 cylinders. These actions may be taken alone or in any combination. As we saw, the new 3100 Generation 3 V6 is the standard engine on Regal Custom and available on 94 Skylark and Century models. A die-cast aluminum oil pan accommodates cross-bolted powdered metal main bearing caps. The ignition and fuel management system on the 3100 SFI is also new. Like on the previous 3.1 engine, a notch reluctor wheel on the crankshaft produces position and speed signals. These are sent to the ignition module, which uses them to generate a low-resolution 3x signal for the PCM. The 3100 also uses a second crank sensor located behind the crankshaft torsion damper pulley. A ring mounted inside the torsion damper has 24 windows that produce a high-resolution 24x signal from the Hall effect crank sensor to the PCM. At each of the 24 pulses, the PCM reads manifold absolute pressure and averages readings over every 4 counts for a more stable signal. At engine speeds below 3,000 RPM, the PCM uses this averaged MAP signal to calculate fuel delivery. The idle air control valve position sensor is no longer needed. The 3100 also has a camshaft position sensor. The 66U PCM uses the cam sensor signal to synchronize sequential fuel injection during cranking. After startup, the PCM primarily uses the low-resolution 3x crankshaft signal to sequence injector timing. You can find out more details on the 3100 and the 66U PCM by watching the Certified Plus training program on this subject. Another upcoming CPT program that affects 1994 cars is the release covering onboard diagnostics, or OBD2. The California Air Resources Board and the federal government have mandated a number of additional onboard emissions-related diagnostic capabilities for all 1996 cars. A generic scan tool must be able to detect engine misfire, monitor catalytic converter efficiency, and monitor canister purge flow. Many of the OBD2 diagnostic abilities are already incorporated in the 1994 Regal with the 66U PCM. For example, an additional O2 sensor is located downstream from the catalytic converter so that an OBD2 scan tool can compare exhaust emission readings before and after the converter. I mentioned the 2200 engine has received a number of enhancements designed to reduce friction and increase performance. Roller lifters replace the hydraulic solid base lifters used in the 93 engine. Also, valve stems are reduced to 7 mm and a smaller piston pin is used for less reciprocating mass. Horsepower is raised from 110 to 120. The 2200 and 3100 engines share a new technology used to form the lightweight assembled camshafts. During manufacture, cam lobes and bearing journals are slid onto a hollow core steel shaft. As the components are held in place by a positioning fixture, a slightly larger diameter steel ball is forced through the shaft core, producing an interference fit with the shaft components. Besides reducing weight, the new shaft design permits the use of different metal compositions for increased durability of cam lobes and bearings. Cams can also be indexed to closer tolerances than on a machined shaft. The world-class 3800 and 4T60E combination continues as the standard powertrain for 1994 Lesabre and Park Avenue, and is still optional in Regal. Buick continues to modify both the engine and transaxle for improved performance. The 94 3800 engine has a new, smaller, single-pintle design EGR valve system. The linear valve operates a lot like the idle air control valve and has a position sensor that enables the PCM to keep track of the pintle for more precise delivery of exhaust gases. The 94 3800 engine uses a new, larger powertrain control module with a GMP6 processor that has more memory and the added capacity for engine-related traction control functions. 3800 hot valve train noise and engine durability are improved by smoothly polished valve stems and closer tolerance machining of the valve guides and seats. The supercharged 3800 engine has received a number of internal modifications to improve performance.
I know you love your job, but we are on vacation. So enough about Buick for today. Mom's ready to serve dinner.
Well, I gotta go. These are just some of the highlights for the Buick 1994 car lines. I think you'll agree, for a year where there are no new models, the changes are significant. You'll find more detailed information in the know-how reference manual with this program. Take a look for yourself, and you'll see why Buick really is the new symbol for quality in America. Like I said, I gotta go. Take care.